Solutions to Sec 1 WA1 2023. In the first sum, we have a 5-digit number 48,000 P23, and this number is rounded to 48,000. Since it's rounded down, therefore P must be less than 5. So P is a prime number, so it could be either 2 or 3, but since it has to be the largest possible, therefore P must be 3. In the next sum, we have to find the unknown base and powers of 5 and 7. To do that, we use prime factorization to break the number into its prime factors in index form. So we have 3 to the power of 3 multiplied by 5 to the power of 2 multiplied by 7. So now we can compare, and we see that x has to be 3 and the power of 5, which is y, is 2, and then the power of 7 z is 1. Next, we have to express the number into the product of prime factors, and we know that 216 is actually 6 cubed, and 6 cubed is actually 2 cubed times 3 cubed, and 1000 is 10 cubed, which is actually 2 cubed times 5 cubed. So we can get 2 to the power of 6 multiplied by 3 to the power of 3 multiplied by 5 to the power of 3. So now we can use this result to evaluate the cube root by writing in index form. We have 2 to the power of 6 multiplied by 3 to the power of 3 multiplied by 5 to the power of 3. So when we take the cube root, we divide all the powers by 3. So we have 2 squared times 3 times 5. So that gives us 60. Explain why the number in A is a perfect cube. So since the powers of the prime factors are multiples of 3, therefore the number in A is a perfect cube. Next, we need to find the HCF of two numbers A and B. Since HCF is a factor and is also common factor, we are looking for a smaller number. We pick the lower power of the common factors. So the lower power of 2 is 2. We don't have 3, which is there's no common 3 and no common 5. So common 11, lower power is 11 cubed. And this works out to be 2662. Next, we want to find the LCM, which is a bigger number, is bigger than A and B. Therefore, we have to consider the higher power of both numbers. The higher power of 2 is 2 to the power of 5. And then we look at 3. Higher power of 3 is there's only 1. And higher power of 5 2023, and higher power of 11. Next, we want to find the smallest integer x such that ax is a multiple of b. Ax is actually the LCM of a and b. We know that the LCM must contain the factors belonging to both. So, therefore, we already have the factors of a. Now we need to have the factors of b. We already have 2. B has a 2 and a has 2 to the power 5, so there is a 2 there. But it doesn't have a 3 cube. A does not have 3 cubes, so we need to put it down. And then the factor 11 to the power 4, what we have is 11 cubed, so we need another 11. So all in all, we have to include the factors 3 cubed times 11, which is 297. Next, we want to find an integer y such that b over y will be a perfect square. We know that in order to be a perfect square, it must have even powers. So that means looking at the number b, if we can get rid of 2, and then we have get rid of 3, then we have a 3 square times 11 to the power 4, which is a perfect square. So that means what we need to do for y must contain 2 to remove the 2, and y must also have 3 to remove a 3, so that the result will be 3 square and 11 to the power 4, which is a perfect square. That means y must be 2 times 3, which is 6. Next, we have a list of numbers, which we must first write down all the irrational numbers. Irrational numbers are root of prime numbers, which is here. Cube root of 27 is 3, so it is a whole number. And then we have pi, right? So we have root 7 and pi. Then the other numbers are all rational numbers. So there are only 2 irrational numbers, the root of prime number 7 and pi. And we have to represent this list of numbers on the number line. Root of 7 is about 2 point something, so we put it down. We have to write down root 7 because it's not on the number line. Okay, so cube root of 27 is 3. So we don't need to write down because the number is there. And then we have 3.142, that is pi. And then 22 over 7, which is slightly more than pi. Next, we have negative 2. And then we have negative 2.7 recurring. Negative 2.7 recurring. Okay, there are 6 numbers. So, and we have 6 dots. In number 6, we can use the calculator and obtain this value, 98.14355, rounded to one significant figure, that is 100. And 6b, we have to estimate the number. So we find the nearest whole number for here, 7, and the root, which nearest root that we can take is root 36. Nearest number multiplied by nearest number is 6 minus negative 4 and square. Okay, we need to do the square root first. Square root of 36 is 6. divided by negative 2 multiplied by 6 minus minus is plus, 4 is 10, 10 squared. So since this is a division and multiplication, we work from left to right. So 6 divided by negative 2 is negative 3 multiplied by 10 squared is 100. So this is just 7 minus negative 3 times 100 is negative 300, and that works out to be 307. So in number 7, we have members belonging to 3 houses, and what we need to do is to get the numbers of people from each house to form a group, and we want to find out how many groups can we form, right? So since we have equal numbers of each house in each group, therefore we are finding the HCF. Right, to find the HCF, we use the division method. We put the 3 numbers down, and then we start with the lowest prime number, which is 2, divide by 2, and then if we can't divide by 2, the next is we divide by 3. And once we do that, we cannot find any more common factor, so the HCF is 2 times 3, which is 6. So that means we can form a maximum number of groups. Maximum number of groups is 6. In the next sum, we have a rectangular tiles, identical rectangular tiles, which is used to form a square. So we are actually looking for a bigger number that represents the side. So what is the length of the side? So we are basically looking for a bigger number, which is bigger than the tiles itself. So therefore we are finding the LCM. So bigger power of 3, bigger power of 5, bigger power of 7. Right, that works out to be 1575. And now we need to find the number of tiles. So the number of tiles in the side is 1575 divided by 75. And the number of tiles in the top is 1575 divided by 63. And that gives us the number of tiles, which is 525 tiles. And that completes the discussion for the WA1 2023 paper. Thank you.